All right, hello and welcome to AWS Made Easy Ask Us Anything live stream episode number 46. We're your hosts, Stephen Barr and Rahul Subramaniam. Oh, unmute for a second. All right, let's try that one again.
Acting like a novice.
I've
I had
done
myself
that
on mute.
a lot of times.
I just got to say that I'm so excited that we're inching towards episode number 50. That feels like a real milestone. And we should do something special to celebrate that.
Yeah, we're almost at the 1 year mark, episode 50.
Yeah.
We do a highlights reel. And I think we said we would have Badri back on at episode 100.
Yeah, that would be pretty neat. We could probably even have him for the 50th episode. But yeah, it's been quite a fun ride. We should probably do a whole reel of bloopers, keeping yourself on mute, transitioning the wrong stuff, not being able to log in at times. So anyway, quite a journey. We'll recap all of that in the 50th episode. Anyway, how was your weekend?
Really good. Let's see. So remember I told you about the shoes that I bought that finally fit?
Yes.
So I got to go on a run for. I did a run, and obviously I have plenty more runs to do, but it was really fun to do that and to not feel foot pain. So I was very excited about that. Looking forward to more runs in the future. Let's see. We had some fun in Seattle with the family. It was a really nice, relaxing weekend. What about you?
I felt like a travel planner through the weekend, where because we have so many events coming up this summer that I'm really excited to talk about. I was literally just scheduling flights, tickets, stays, stuff like that, just to figure out how I can optimize all of my travel. The jet lag with traveling from India to anywhere in the US and back is pretty bad. And as I'm growing older, I find that it just hits me a lot harder. So I was trying to minimize my back and forth. I think right now I'm down to 4 trips that I'm going to make over 2.5 months. But that's a pretty large number as well.
What is your jet lag reduction strategy? Some people say try and stay up until the end of the day, wherever it is that you land, or what's your strategy?
So usually when I come to the US for meetings and for work and for AWS events and stuff like that, I think just the energy of the place keeps me going for 2-3 days straight. So I usually end up in those highly sleep deprived situations at the end of these events, after which I just crash for a while. And that helps on my way back. So if I'm taking a flight immediately after an event, if I'm flying all the way back to India, I just sleep right through it. And these flights land literally in the middle of the night, or I think like 4 a.m. by the time I get back to India. So I am set to go. It's not too bad, but I think 3 or 4 days later, like there's going to be one day that hits me so hard that I can't function during the entire day. But barring that, it's okay.
I had one of those crazy travel weeks once a long time ago, and I woke up in Chicago O'Hare Airport on a bench of seats, having missed my flight to getting back home, which was Rochester, New York at the time. So woke up disoriented, having missed my flight, trying to figure out how to get back. So I had to save a little bit extra for that connection.
Yeah, I just took one more nightmare scenario, after which I actually reduced my travel drastically. There was a time, I think this is 2013. There was an 8-week period where I was literally doing a Dubai, New York, or Dubai, London every week. And so I would go back and come back, be there for the weekend, and then fly to the next destination. At the end of 8 weeks, I was so disoriented. Like I wouldn't know when, like I would just suddenly crash and fall asleep. And I would have no idea of when I got up where I was. And finally, my wife and I, we went to a movie. So I sat down, and the first thing that I was looking for was a seat belt, which
must have been an exciting movie.
But I was like, okay, that's the limit. When you're looking for a seat belt in a movie theater, I think that just tells you that you were traveling a little too much.
Yeah, absolutely.
But anyway, back to the events. We have a lot of exciting events coming up this summer. We have the AWS Summit that's happening in London, where we're going to be there. We have the AWS Summit in Toronto in the middle of June. We have FinOps X, which is going to be in San Diego at the end of June.
Yeah, no, I
And
put it on the list.
last but not the
63
least, so that's
days.
27th to 30th. We're all going to be there. And then last but not the least, there is AWS Summit in New York, which is at the end of July. So lots of very interesting events. We're going to be there in person. So please do come by, come talk to us. We'd love to meet you. And yeah, it would be good to just hang out.
Yeah, absolutely. That would be great to see everyone and meet in person. It's really refreshing. You know, I love remote work. I think it's the absolute way of the future, and it makes those in person meetings even more special.
100% without a doubt.
All right. Well, should we jump into our first article, which is we have a great show today. We've got three announcements from AWS, and then we're going to do a deep dive into reducing your AWS costs by eliminating idle elastic load balancers, and that's both the classic and the V2 ELBs. So we'll dive into that when we get there. Should we start
Let's do
with
it.
EMR serverless?
Awesome.
Okay. Amazon EMR serverless adds job level build resources for efficient cost management. I'm putting this one in the comments so you can follow along with the article.
Yeah.
Serverless
And
option. What's your read on this one?
yeah, so the interesting, if you remember, we had a conversation last week. We were talking about two other services like ECS, where they introduced this resource level billing for ECS, where you could actually distribute your costs. For jobs that are running on EMR and serverless at that, again, just like these common pieces of infrastructure that you keep around and run tons of different jobs on it, having that resource level billing really helps with your FinOps goals of chargeback and showback. I emphasize more on chargeback because I think that's the more actionable um, actionable thing to do, which actually changes behavior, changes outcomes. Showback is possibly an intermediary step where you take all the billings, you then show your teams what they're spending on these resources so they can change their behavior. But chargeback works a lot better, where they have to pay for it, so they make sure that they are prudent in their spending when they are charged for whatever they use. So one of the big challenges with a lot of these services that are kind of like central monolith infrastructure, where you just run these different jobs depending on what you want to do, it was historically really difficult to charge all of those back. Invariably, you'll just equally distribute those costs across all the parties that are using those resources. But even then, there are teams that will come and say, no, this is not really what we are using these resources for, or we are just using a fraction of it. So it always felt unfair. Now that you can do this at the job level, you can charge the teams back for exactly what they used. And you can also then figure out what is waste, because the delta between what jobs got used and what didn't is wasted money. Actually,
And
in the case of serverless, there isn't wasted money.
and it's the teams themselves who are going to have that low level knowledge of
Correct.
exactly how their spend works out. It makes me think back to my Econ 101 class. What's the fundamental axiom of all economics is people respond to incentives, right? And
Yes,
being able to align the incentives and the billing so that they're all the same thing, right? Because I think we talked about this last week. If you just pool all the spend into one pot, then people just have a tendency to overspend, and that's
correct.
the tragedy of the commons applied to budget. Whereas
Yeah,
if you want to really make sure that each team is acting efficiently, then the easiest way is just to let them pay for their own usage.
correct. I mean, there is one tip that I share with a lot of people, and invariably, I receive, gasps of disbelief when I tell them about this. But I've found that the most effective way to implement a FinOps practice and discipline and behavior change in a large organization is to use chargeback as effectively as you possibly can. And what I mean by that is, if you take your chargeback and you want behavior to change very quickly, charge back in multiples of what they spend. Okay. So for the behavior that you don't want, make sure that the chargeback is 2x or 3x or 2.5x, like whatever the number, but let it be a multiple. And for behavior that you absolutely want, offer it for free to your teams.
Interesting.
Okay.
So you can increase the price of, say, let's see, what would be a behavior that you wouldn't want? Maybe you want
I'll give
people
you an
to switch
example,
off of
like
EKS
RDS.
onto serverless. Okay.
Yeah, let me give you a simple example of RDS, right? We had teams that were launching RDS instances willy-nilly, and they would over-provision these instances like crazy. So we were like, okay, for whatever RDS instance you use, we are going to charge 2x. Okay. But we have this centralized RDS instance that all the developers and staging environments and all can use. It's a super massive cluster, so the performance is much better. You can get a database on that in a matter of seconds, just like any other RDS instance. And that one, by the way, is free. Okay, so we spoke about this last week, where we have more than, I think, somewhere between 2,000 and 4,000 schemas on a single RDS cluster, Aurora cluster, which is amazing. And that behavior happened overnight. When businesses know that they're going to be charged 2x while something else is absolutely free, they will change their behavior pretty immediately.
No, that makes a lot of sense. And say if you just invested in serverless training for your whole organization, then maybe you'd further want to disincentivize maybe RDS and have people start shifting over to, say, Dynamo or
Yeah.
or any other type of serverless data store, serverless architecture. So it's a really neat way of shaping behavior within your organization. And EMR serverless is just one example of being able to do that. So digging into the core of this announcement, let's see, looking at this, you can look at individual job runs to understand and manage your total cost. The idea here is you would have an EMR cluster that's centralized, but different teams could be using it, and each
Correct.
team would be using it for a particular job. So you can say, how much resources does this particular job take?
Correct. It's basically a cost group by query on the job. So it's really straightforward. It's actually not convoluted. And the fact that it's with serverless, it makes it way simpler as well. It'll scale up and down and just tell you exactly what resources you use. So I would give this simplifies without hesitation. And this gets 4 out of 5. It's really simple.
Pretty good. So what would it have taken to get them a 5? I would think they would want an example or a more let's see, some more details available if you were interested.
Correct.
But overall, I like this announcement. I think it's really important to be able to, like you said, account for things at a job level, so that way you don't get this abuse of this common resource. And although
Correct.
you'd like to think, okay, we're all on the same page, we're all on the same team, everyone should minimize. That just isn't the behavior that we have to take into the account that we are all humans and optimize for that use case.
Behavioral economics plays such an important role in how people use shared resources.
Absolutely. All right, well, let's hear our message from Cloudfix. It's really exciting, some of the developments that are happening in Cloudfix about automation, about automating your cost savings. So we're going to hear a quick message from Cloudfix, and then when we come back, we're going to jump into the next announcement, which is EFS, an announcement relating to EFS. We'll be right back.
Great.
Public cloud costs going up and your AWS bill growing without the right cost controls? Cloudfix saves you 10 to 20% on your AWS bill by focusing on AWS recommended fixes that are 100% safe with zero downtime and zero degradation in performance. The best part? With your approval, CloudFix finds and implements AWS fixes to help you run more efficiently. Visit cloudfix.com for a free savings assessment.
All right, let's cue up the transition for EFS. All right, this is Amazon EFS now supports up to 10 gigabytes per second of throughput. I wanted to quickly mention on the CloudFix blog, where we're diving into later, we have two different articles about EFS. There's one, here we go. There's the Optimize Amazon EFS storage costs with EFS intelligent tiering, and also looking at EFS intelligent tiering with two different articles. We've got a support knowledge base and then a blog post on this. So go check these out on the CloudFix blog. Now, today we're going to be talking about EFS now supports up to 10 gigabytes per second of throughput. So why is this important?
Okay, so the reason I picked this one for this week's discussion is when I first started using EFS. Okay, for those of you who are not familiar with EFS, EFS is, I think in simplest terms, it's a lot more complex than that, but in simplest terms, it's the NFS equivalent in the cloud, where you have a common file store that can be mounted onto multiple different instances, and it operates kind of like NFS, though fundamentally it's architected very differently in AWS. But for the simple mental model, I think NFS is probably the closest that it comes to.
You can think of it as a NAS, right? It's like a big network attached storage that you have access to from your instances.
Correct. And the interesting thing about EFS is it is used in scenarios where there are a lot of instances where you have data that is laid out in such a manner where you have to share one common instance. I'll give you an example. When you have very, very large GitHub repositories and you want to analyze your GitHub repository and the code in it across all the revisions, then the only way to do that is to put that on an EFS system and run parallel compute. So mount it on multiple different machines so that they can process all the data in parallel. And the limitation comes from the fact that all the Git repositories are basically compressed zip files that you don't want to keep uncompressing over and over again. You just want to get it in one place and make sure that it stays there. And there are tons and tons of files. You can't copy them over, all the time. It's just too much network bandwidth. The latencies are just too much when it comes to trying to copy everything over multiple times. Moreover, you're going to spend, so let's say you had a 10 gig Git repository. If you're going to run this across 100 different instances for parallel analysis, you don't want to spend a terabyte of storage costs just to do that. Not to mention that it's going to take you hours to just copy over that 10 gigs over and over again.
And then you could use S3 because you want the Git depends a lot on the underlying file system more than what you could use with the S3 abstraction. That's a lot more of a simplified interface.
Yes, and S3 is an object store, right? And S3 does really well when you have large files. The problem with Git is that Git has tons of very, very, very tiny files. They're literally a collection of diffs between one version and the other. And that doesn't do well in S3 at all. Correct. So you would actually, if you ended up putting or transferring your data to a different tier, for example, in S3, you would spend a bomb. So there is, take a look at, I think we've covered it in one of the episodes. There's a minimum, or there's a CloudFix blog post, I believe, on this, where there is a minimum size of an object that should be considered as you're moving them from one storage tier to the other, because otherwise your transfer costs outweigh the savings that you get on these. And I think it's something to the tune of 16 KB or 4 KB as a minimum size.
I think it's 4.
4 KB? Yeah, I'm trying to remember the specific numbers. But anyway, those are the scenarios where EFS makes a ton of sense, right? There's a specific use case for it. Now, if you had used EFS even 3 or 4 years ago, you would have come across the problem of taking a file, unzipping it on EFS just was painfully slow. Your local machine would seem like it was 1000x faster than EFS, because operations that did a ton of different writes on different file objects was just incredibly bad. So now, and by the way, this has been happening throughout the last 3 or 4 years. The number of improvements that have happened on EFS, that continue to happen on EFS, are just absolutely fantastic. You can now get 10 Gbps of read throughput, which, if there's a processor that's processing files that are sitting on a common file store and everyone is writing back to the same one, it's an incredibly efficient way to do this with 10 Gbps of read. And write throughput of 3 Gbps is also pretty incredible, because you're going to spend most of your time reading all the data, doing some processing on it with the compute, and then writing back the results into the same store. So it's pretty amazing that EFS has come such a long way. And the reason why I also brought it up was, I think most people don't like 2 or 3 years ago, someone could have made an argument that, no, I'm going to just stay on-prem because NFS on an on-prem system works so much better. But if you had stuck with EFS and worked with the AWS team through all of this, today you would have a product that is far, far, far superior to anything that you could have imagined on-prem. You couldn't even come close. So I think the folks who keep comparing the on-prem infrastructure to cloud and look at just-in-time or instantaneous costs, they miss out on the long-term view that over a period of time, AWS just gets incredibly, stellar at all of these services.
Whereas your on-prem stuff just gets worse. It just,
and on-prem stuff just keeps getting worse.
Your hardware ages, everything just sits there, and you have to keep maintaining, you have to patch, you have to deal with security.
Exactly.
It's amazing with this EFS announcement. So now, normally you would have thought your alternative, if you wanted this fast of a file store, is to have a large EBS volume, a large EBS attached volume. Is that what would be your alternative before this EFS?
Actually, EBS doesn't really serve that purpose, because if you wanted to mount that file system across multiple different instances, you just couldn't. I think there was one mode in which you could attach one file system as a read replica to a few, I think up to 3 or 4 or 5 instances. I think there's some way to do that in EBS, but I think that's a hack. I wouldn't recommend that to anybody.
Yeah, I suppose you could host your own NFS server, but that would be
I have seen people host NFS servers, but you will not get anywhere close to the performance of EFS with those hosted NFS servers. So my recommendation would be to just use EFS. It's way simpler to have an EFS mount point available to you, completely managed, completely serverless in a sense. And you can just mount those endpoints to any instance.
Absolutely. Look, we got a really good comment on LinkedIn. I'll put this up. Jeff says your file systems get more throughput with no action at all on your part. Far better than adding more drives, controllers, network interface cards, cables, routers, and so forth. So yeah,
completely agree.
And it's neat. I was just reading this in the announcement. The increased throughput limits are immediately available for EFS file systems using elastic throughput mode in the USE. So thanks for joining us, Jeff. We really appreciate the comment. It's great to see that, and yeah, we're really excited about this new EFS announcement. So what do we give this? I think the rating is pretty obvious.
It simplifies.
Up the simplified graphic.
Yes, absolutely simplifies. And I think just the announcement is straightforward. And if I think this is a 4.5. I'll always leave half a point, but there isn't much to it. It's just really important to know that you got this new throughput, and it's all immediate. It's available right there for you to use. So
this is US East, the 2 large US East, US West 2, and Dublin. So it'll be exciting to see this. I'm sure we'll see more of the region-specific announcements of this type of this feature being supported over the coming months, probably.
Exactly.
All right, let's take another quick break to hear from our sponsor, from Cloudfix. We're really excited. And then we're going to talk about EC2 Inspector. We will be right back.
Great.
Public cloud costs going up and your AWS bill growing without the right cost controls? Cloudfix saves you 10 to 20% on your AWS bill by focusing on AWS recommended fixes that are 100% safe with zero downtime and zero degradation in performance. The best part? With your approval, Cloudfix finds and implements AWS fixes to help you run more efficiently. Visit cloudfix.com for a free savings assessment.
Okay, I had to do a custom transition for that one, and that's my my motion graphics abilities this morning. But I can't do an inspector
Yeah.
without having the inspector gadget theme.
Yeah, and it had a little bit of this quirky sinister tone to it, but AWS Inspector is actually pretty awesome. So historically, if you needed AWS Inspector to operate on EC2 instances, you had to install an inspector agent on all the various instances. But now you have all that same deep inspection, security vulnerabilities, all of that available to you without having to individually set up those agents. SSM agents, just which, by the way, should be installed by default on all instances. They are now available. So just using the same SSM agent, inspector is able to now perform deep inspections on whatever is running within your application. It brings all the data in, it does the analysis, and it can report in multiple different platforms, everything from Security Hub to the inspector page itself. It will tell you, or even you can direct all those messages or events into Event Bus and have it be processed by whatever other system that you are using to process these scenarios. So really, really cool. It's available with AWS organization. So now you don't need to, you can centrally manage it. You don't need to manage individual accounts or individual instances manually. It just works at the org level, and you can get this holistic view of what's happening with your vulnerabilities.
Well, and especially just looking over the list for Python, for Java, and Node.js, right? I think that is the wild west of bringing in packages. And so being able to have a centralized place where you can inspect those and to make sure that your code is, that you're not bringing in some package that then has some problem. And that's, I think with all modern languages that have these enormous libraries of dependencies, being able to search these and make sure that you're not bringing in some rogue code or some buggy code that has been flagged as a vulnerability. You want to make sure that you get alerted for that as quickly as possible.
Correct. And the nice thing about AWS Inspector or Amazon Inspector is that it gives you very contextual insights about what's going wrong. And in the past, I've actually used it with Lambda. That's another one that you should check out. AWS Inspector or Inspector for Lambda is incredibly valuable because it can do that. So if you're using Docker, for example, or you're using containers, your Lambda is organized in layers, and it can literally tell you where the vulnerabilities are on a layer basis. So you can just go change or replace a particular layer without having to replace the entire stack. So a lot of deep contextual insights on vulnerabilities, which are really easy to run through as an exercise and close out. And yeah, I would recommend everyone use it for any external facing service component, Lambdas, or any code that's externally facing.
There we go. Inspector automatically discovers all of your EC2, ECR container images and Lambda functions at scale and continuously monitors for known vulnerabilities. Now, this replaces an enormous amount of work that you'd have to do and gives you this huge reassurance. I mean, for people who used to run LAMP stacks manually back in the day, if you weren't aware of particularly like MySQL, right? If you didn't update MySQL the second it came out, your website would be defaced and horrible and not what you wanted it to be, right? And so being able
Correct.
to have a centralized place where this can be monitored, and of course you want to have your own security policies in place, but just having this layer of protection where people are monitoring all of these packages and all of this different code that you're pulling in. It's amazing thinking about
Exactly.
the code that we're running is probably, in terms of the lines of code running, it's like 1% that we write ourselves and 99% that we're bringing in from the outside world.
Exactly.
And so being able to validate that 99% that we probably didn't take the time to read and double check by hand, just to make sure we're all
Correct.
bought in, make sure that these packages are doing what we hope they're doing.
Exactly. So this one simplifies. For me, the biggest simplification here is the fact that A, it's part of AWS organizations, so it's really easy. You don't have to go account by account setting this up. B, the fact that now it's all managed by SSM agents itself. So as long as you have the SSM agent, all of this other stuff kind of comes, without needing to do anything else. I still see tons of accounts which don't have SSM agents installed on all of their instances, and I would seriously recommend set it up. There are a lot of important, I'd say, monitoring and what do you call it? Yeah, there are a lot of very important tools.
You get better CloudWatch metrics. It's
correct. There are a lot of observability and change management tools that just become really simple, or change management activities. They become really simple when you have the SSM agent installed. Even simple things like monitoring memory metrics, right? You just don't get a bunch of that stuff out of the box. So if you don't have the SSM agent installed on your instances, you are basically in for a lot of pain in the long run.
Well, actually, there's a blog post coming out on EC2 instance right sizing. And then what we recommend is when you right size an instance, so typically if it's over provisioned and then you resize it, you can wait for Compute Optimizer's recommendations to come through, but that takes 24 hours. So we recommend setting up a CloudWatch alarm that depends on the SSM agent to make sure that your memory usage stays under a certain threshold. And that's a much more responsive, reactive way of doing things than simply waiting for Compute Optimizer's recommendations to come through, which might take a 24-hour cycle. But Compute Optimizer is for a long-term view, not this immediate view, but it only can deal with the data it has access to. And your with Compute Optimizer, you can enable the enhanced infrastructure metrics if you have the agent installed.
Correct.
Nate, so what do we rate this one? Give it a simplifies.
Simplifies and a 4.
There we go. Great. And I've put the link to this in the comments. So that's the article that we have for today. And so the next thing we're going to do is we're going to do a deep dive into cleaning up idle elastic load balancers. Now I'll put the link to this blog post in the comments, and then we're going to switch over to that.
Fantastic.
Okay. Here we go. All right. Now
the diver always cracks me up.
let's switch over to a different view here. I will put this up here, and then we'll take this out of the stream. Okay. And so the magic of green screen, we're doing cleaning up idle elastic load balancers. Let me full screen this on my end here. There we go. Okay. So idle elastic load balancers. This is similar to things like elastic IP addresses, other small bits of infrastructure that, this isn't going to be elastic load balancers. They're not expensive individually, but it's easy to accumulate them over time. And you want to get rid of them because why pay for a resource that you're not using? So let's jump in and find out the details of elastic load balancers and how to get rid of them. So what is ELB? Now, I like the ELB logo because it's one of a lot of the service logos are somewhat abstract, but this one, it's very clear to tell what it's doing, right? You have something big in the front distributing to small things on the back, right? So rather than having one giant EC2 instances, maybe you can have several smaller EC2 instances that are taking part of the application load. A long time ago, we used to call this like DNS round robin, right? Where you'd actually play tricks with DNS in order to distribute your load among different servers. But now we can use Elastic Load Balancer to do the same thing. Now, there's ELB is interesting in that there's two versions of the service that both run in parallel, and they work slightly differently. So at a high level, it distributes load. So we've got classic ELB. And what that is you give it a list of EC2 instances. You do what's called you register them with the load balancer. And then the EC2 instances that are registered can then take part of the load. And they're doing this at a per request level. So if you have a request coming in from a certain IP address, it will route that to a certain EC2 instance on the back end and keep that session going. But it can't do anything intelligent on an application level. Now, ELB v2, we have network, application, and gateway load balancers. The application load balancer is the most similar to classic ELB, but it's in the ELB v2 framework. What about network load balancers, network ELBs? When do we use those?
Yeah, so the application load balancers are primarily used for HTTP-based requests. So you would basically have, there are two kinds of requests you can do. You can basically move the load to a particular HTTP port or HTTPS port, and you can set up your routing rules accordingly. Alternately, you can also do URL-based routing. So you can say for a given URL, you want it to route to a certain set or subset of instances, you can do that stuff as well. So all of that comes in the application load balancing. Network load balancing is typically used for things like UDP and raw TCP connections or different kinds. Those get handled by the network load balancer. And the gateway load balancers are where you basically have routes. Let me get my description right. So I believe that the gateway load balancers are more for handling network traffic in and out of VPCs.
Yeah.
Or whatever network setup you create.
Yeah, and those are the ones that are the most, I suppose, those are the most different than the classic ELBs. And it is, I like how you pointed out with application load balancers, you can actually inspect the packets and do URL-based routing. So if you had one part of your API that say if you're doing hosting an LLM as part of your API and you had a GPU-based instance for one of your endpoints, right? You can route those requests to those endpoints, and then the other ones can be to simpler ones. So that's how these ELBs work.
Correct.
And so I made this diagram almost as a little fractal, because if you notice, the layout of the EC2 instances is kind of the same as the image itself. So this is how it works. You have an incoming load, it's distributing to ELBs. It costs about $200 per year for an ALB, NLB, or classic ELB. Gateway ELBs are about half that. And then they're billed at between 4 and 8 cents per what they call work unit. So it's basically just how much traffic they're routing, and then depending on whether it's a network or whether it's an application that's either billed in basically amount of stuff it's doing, amount of throughput,
Correct.
the billing unit. So for an idle ELB, you're not going to pay for those work units, but you're still going to pay that fixed cost, that hourly cost. And if it's idle, you'd have no reason to do that. So
correct.
Define idle. What we're saying idle is no traffic routed in 90 plus days. So if you had a quarterly report coming out and you had some infrastructure that stood there for 89 days, and on the 90th day produced this big report that needed a load balancer, that you could do that and we wouldn't consider it idle. But anything longer than that, we'd say, okay, that's idle. Now, the downside of idle ELB is cost, and also just an increased complexity and increased service. Anytime you have, if ELB was running and it wasn't used, that might be attached to some network security policies or other things. And if it's just standing there, you probably want to get rid of that, just from a, I suppose, hygiene perspective, from security perspective. The less things you have open that are routing packets around, the better. So you want to get rid of these just from a complexity standpoint, let alone a cost perspective.
Correct. And more often than not, the reason why I've seen a bunch of idle ELBs kind of sit around is that someone built an application and they got it up and running, Now, they didn't want to tear it completely down and restart, full-fledged deployment with an ELB in front of it. So instead, what they do is take a little bit of a shortcut where they deploy two instances of that application independently, like two stacks, and then they put an ELB in front of it. Now, when they tear down all instances of a particular stack, because they know that they have stack sets available, when they tear those down, the stacks go away, but the ELBs stay because they were manually added in front of a bunch of other resources. So I've seen tons of that happen, especially in dev and staging environments, where for load tests and stuff like that, because somebody didn't build the script for a load test to actually have multiple different machines behind a load balancer. The testing team literally will set up a load balancer and just launch a bunch of whatever they decide is the scale. They'll launch a bunch of stack sets in front of it and run it, and then they'll just tear down the stack sets and leave the ELB as is.
Yeah, in an ideal world, every last bit of infrastructure would be traced back to a CloudFormation template or a Terraform or some
Right.
bit of code that's checked into a Git repository and implemented via CI. But that's not always the case, especially when you're moving fast, you're testing, you're just getting into the management console, setting up a few things that you think, oh, I'm setting this up just for a test, but then it works, and then that problem solves, you move on to the next thing, and
Right.
before you know it, you have an ELB that's just sitting there. So before we dive in to all of the complex way, I want to mention this is the easy way to do it. Is use CloudFix. All the automation that we're about to talk about is already built in, and especially for idle ELBs, because there's two parallel but slightly different code bases that are running for Classic and for ELB v2s.
Correct.
And there's plenty of Classic ELBs that are still out there in the wild, in your infrastructure possibly, and the approaches are different. So you could do all of this manually, and we're going to show you how, and we're going to show you the reasoning behind some of our decisions and some automations. But the easy way is to just use CloudFix, turn on the cleanup idle ELB fixer, and it will do all of this for you, and continually monitor. I think that's one of the biggest things about automation is that it's always running, because you could do a cleanup idle ELB pass once, but you're going to have new ones come up because developers are going to keep causing them to exist.
Yeah, 100%.
And also with the scale, right? Because each individual ELB is $200, right? So if you invest an engineering effort into this, you put a few people on it for a week, it's going to take a while for that to recoup that cost. But if we've already done the work for you, then you could just enjoy that right away. All right. Let's talk about the manual way. Here's your two checklists you have to do. For ELB v1s, you have to figure out if they're idle. Then you want to deregister the instances from the ELB. So that deregistration process, the ELB is going to be mapped to an instance. You have to break that mapping. And then once you've broken that mapping, so the ELB is kind of empty, then you can delete it. Now for ELB v2s, you have to use a slightly different CloudWatch metric. Instead of request count, we use process bytes. And that process bytes metric, the good thing about that is that metric spans the three types of ELB v2s. So there's actually four different entities here. There's the one type of ELB v1, the classic one, and then the three types of ELB v2s. And so we found that the CloudWatch process byte metric works for all of the v2 ELBs. And then with ELB v2, sorry, I'm drowning in the AWS acronyms here. With the v2s, there's a higher level container called a target group. And so the target group is like a list of instances that exist, or could be a list of network gateways or application endpoints, whatever it is. But that's a higher level container. So you have to delete the target groups because one ELB v2 can be associated with multiple groups. So you have to iterate through each target group, iterate through each target within each target group, then disable the protection on the ELB, and then you can delete it. So let's dive into the particular commands that you'd want to run in order to do this. Okay, so for ELB v2, you want to run this describe load balancers command. And this is going to return you a list of load balancers. And you can keep track of the load balancer ARN. That's going to be your uniquely identifying string for that particular ELB. Now, interestingly enough, for classic ELBs, they don't have ARNs. They were invented before ARNs were. So you can't use ARNs with those. That's kind of one of these interesting historical artifacts. So in order to identify them, it's name and region. That pair is unique, or the DNS name is unique. So that's what you have to do to identify classic ELBs. So it's kind of neat, right? Seeing this piece of history here. All right. So now you want to query CloudWatch to determine idleness. So this first query here is for ELB v1 classic, and you can see that in the AWS, in the namespace there, that says AWS/ELB. You want to query the request count. And then what I've done here is a little bit of bash work using the date command. So you can actually use in the date command, you can say 90 days ago with the -d flag, and it will figure that out for you. So you can specify a start time and an end time this way. And this period, this 86,400, that particular integer should be familiar to programmers. That's the amount of seconds in a day. So it's saying on a 1 day basis for 90 days, give me the sum of requests. And then in V2, this is for the application ELB. So note that each type of ELB V2 has its own namespace, but you're querying for process bytes. And also note that you are you're querying it by ARN, whereas here you're querying it by name. So they're slightly different, but the kind of spirit of it is the same. And then what you get back is you're going to get back something like this. It's going to show you, here's the statistic that you requested, and you want this number here to be 0, meaning nothing passed through it over that 90-day window that you specified. And if that happens, then you can consider that idle. Okay, so now let's talk about removing classic ELBs. So we had this query, and remember we had this this name. So now you want to use the AWS ELB command and use this deregister instances from load balancer. So when you do this query, it's going to give you an array of instances. In this case, it has one instance, but you're going to want to run this deregister instances query for each instance in your load balancer. And that's going to detach that, so that way the ELB, they want to make sure that the ELB isn't still being used. It's not still configured to distribute traffic to anyone before you delete it. So it's almost, in a sense, a bit of protection against deleting a configured and active ELB. So you have to detach that instance, and then you can delete the load balancer itself. And you do that by name using the -- load balancer name flag. Okay.
Correct.
All right. Removing V2 load balancers. This one is a little bit more involved because, again, we have that target groups. So you want to use the ELB V2 command set, and you want to use the describe target groups command. Now you can specify a region here, or usually that's baked into your environment variables, but you're going to have to iterate again over all your regions. And that's another reason why you want to use the CloudFix automation. We do all the regions, because there's a couple of loops, right? It's for all organization, for all accounts in your organization, for all regions in each account, for all ELBs in each account, for every target group in the ELB, right? The nesting of loops is a lot.
Correct.
So automation here wins the day. So here you query the target groups by specifying a load balancer ARN, and it will give you back a list of target groups. And the target groups have their own ARN. So that makes it easy. You're going to get a response like this that has a list of target groups, and then you would keep these target groups ARN. Then you can query the targets within a group. Now, the way to do this, it's slightly unintuitive. You can use this describe target health command and give it a target group ARN, and it's going to give you the target group health, but as part of that, it will give you a list of targets. And so here is what it would look like. You have this target health descriptions, but within that, there's a list of targets, and then targets are specified by ID here. So in this case, they're instance IDs, but again, if you're using a gateway load balancer, it might be, or a network load balancer, they might not be instance IDs, but they're still IDs of entities that you will then have to deregister. So once you have all the targets within a target group, you're going to iterate over this. This exists as, your 7th level deep in a nested loop. You want to deregister your targets. So if you specify your target group ARN, and then luckily you can list your targets, multiple targets in one command. Once that has been successful, then you can delete the target group. And then once you've deleted all the target groups, because remember, you can have multiple target groups associated with an ELB-v2. Once you have deleted the target group, then you can delete the ELB-v2.
Yeah, with this, I think the complexity of the system is so incredible. If you start putting together the permutations and combinations of the number of ways in which you could get this wrong, and the number of edge cases that you hit, making sure that you've covered every one of these scenarios, it's baffling. I can't imagine how someone would try to do this without automation.
And so I put together this flow chart. And again, if you have automation, this is disorienting. Okay, here's your classic one. And again, just to summarize, for each classic ELB, you're using the request count metric, and you have to deregister and delete. For each ELB v2, you're going to want to iterate over target groups. Yep. For each target group, iterate over all the targets. You use the process byte metric to find the idle ELBs. But then once you've found that, then you deregister every target from its target group, delete every target group from its ELB. Then you have to disable protection, and then you can delete the ELB v2. So this is the diagram showing what you need to do to clean up idle ELBs. And if you have this running every day, looking at that moving 90-day window, that will clean up your idle ELBs for you.
Correct.
Again, this is all already done in CloudFix, which is really, really exciting, because this is one of those things where you get the benefits of it at either end, right? If you only have a few idle ELBs, then it's not going to be worth the effort to track them down.
Correct.
And if you have a lot of them, then you need to use automation to track them down.
Exactly. And I think, usually I put ratings for the AWS articles, but for this particular deep dive, the one thing that's been coming to my mind constantly is that warning sign that says, don't try this, like you say, don't try this at home. I would put a warning sign saying, do not try this manually. You will likely mess something up, because these aren't simple, straightforward steps. They have a bunch of edge cases and things to consider. So use an automation to simplify your world. Automation in CloudFix, for example, is tried and tested, so you can rely on that. But whatever you should decide to use, do not try to do this manually.
Yeah, you're going to end up deleting. You could see you're going to end up deleting an EC2 instance or deregistering the wrong instance from the wrong thing, and it could possibly break something. So
correct.
Whether it's CloudFix or your own automation, just use automation and test this thoroughly to make sure that it's doing what you think it's doing. All right. Well, that is our deep dive into ELBs. Let's go back to side by side. All right. Well, it's been a really fun show. Well, how's the rest of your week looking?
Again, just events and stuff at CloudFix are taking up pretty much all of my time. The other area that's actually becoming very, very exciting is that we are diving deep into a whole lot of new AI stuff across our entire portfolio. So I couldn't wait to, announce all the specific improvements that we are seeing in our products with all the new AI stuff. I'm waiting to get my hands on Bedrock and try out the new AWS Titan model. We've not yet been approved for it yet, but hopefully we'll get that done this week. So looking forward to that.
Absolutely. It's the LLM world. I'm using LLMs all the time. It's really exciting to be able to have this tool to kind of play with language, and not just language, but I use the generative art AI a lot. It's funny, my younger ones, my kids, they use the Midjourney AI to generate pictures that then they print out and then color in. And that's been a really fun workflow, because typically you find these coloring books and you're stuck with what they give you, but now they can create whatever they want to and then color it in themselves. And so they're just using them as creative tools, as introspective tools of sentence rewriting, as programming aids. And I think we're just barely scratching the surface of the potential of LLMs. But
I
it's
couldn't agree more.
we have
I
this
couldn't
very
agree more.
powerful tool at our disposal.
Yes, it has to be used with caution and a good understanding of exactly what it is. Understanding its boundaries, understanding limitations, and then using it in the most creative way possible. I mean, that's the whole challenge of software. So couldn't be more excited about this time.
Absolutely. All right, everyone. Well, thank you for watching and thank you for comments. And we're looking forward to seeing you next week. We're going to have another deep dive. We're going to have more articles to review. And maybe we will, hopefully, we'll have access to Bedrock. If not next week, then coming soon. All right.
Absolutely.
Have a
Thanks,
good one,
everyone.
everyone.
Bye.
Is your AWS public cloud bill growing? While most solutions focus on visibility, CloudFix saves you 10 to 20% on your AWS bill by finding and implementing AWS recommended fixes that are 100% safe. There's zero downtime and zero degradation in performance. We've helped organizations save millions of dollars across tens of thousands of AWS instances. Interested in seeing how much money you can save? Visit cloudfix.com to schedule a free assessment and see your yearly